At Init College, a YouTube channel for high school mathematics education. Mathematics 5, Swedish High School Education System. Mathematical Induction. Hi, this is Babak. In this video I am going to solve the following problem for you. Consider the function f of x equals to sine of ax plus b, in which a and b are real numbers and a is not equal to 0. Use mathematical induction to prove that the nth order derivative, this means the nth order derivative of this function, can be obtained from this formula. I recommend you to pause the video now and try to solve this problem yourself first. Okay, now let us start solving this problem. Before starting solving this problem, I want to prove an identity for you that might be you are familiar with it from your trigonometry studies. And that formula is this. If theta is an angle, then I want to show that cosine of an angle theta can be written as sine of that angle plus pi over 2. Okay, so of course we know that because pi over 2 minus theta are complementary, then sine of pi over 2 minus theta is equal to cosine theta. This is always true, but this sign here is different. We have here addition, but we want to show that again this is the case. How should I prove that? I will use the addition formula. So if you remember from your trigonometry studies, we have the sine of u plus v is equal to sine of the first angle times cosine of the second one plus sine of the second one multiplied by cosine of the first one. Yes? Okay, here I will start from the right hand side, and then I will use this addition formula. So here theta plays the role of this u and pi over 2 has the role of this v. So this becomes sine of the first one cosine of the second one plus sine of the second one cosine of the first one. Yes? But you know that cosine of 9 pi over 2 is 0, and we know that sine of pi over 2 is 1. So if I replace these values here, the first term here that you see becomes 0, and this simply becomes cosine theta. So it becomes 0 plus cosine theta, and that is cosine theta. And that is the left hand side. Okay, so remember this formula. We will need this in the proof of this problem. Okay, now I want to use mathematical induction to prove this. How should I do that? First, I need to confirm that P1 is true. So it means that I need to show that this statement is valid for n equal to 1. Okay, what does this mean? This means that f of the first order derivative of x is equal to a to power 1 sine of ax plus b plus 1 times pi divided by 2. So this is the question mark. We want to show that the first derivative follows this rule. Of course, you know that when we are talking about the first derivative, we don't use this symbol, we just simply write f prime. But here they actually mean the same thing. Okay, how should I do that? Okay, a function is given to you. You want to show that the first derivative of this function follows this rule. Okay, what should I do? I have my function f of x equals to sine of ax plus b. I want to calculate the first order derivative of this function. So I have to use the chain rule. So I know that if I have, let me write it like this. If I have sine of a function of x and I want to take the derivative of this, of course the derivative of sine becomes cosine, but if u itself is a function of x, according to the chain rule, I have to multiply it by an extra u prime. So here I will give the role of u to this expression, so f prime of x becomes cosine of u, f prime of x becomes cosine of u, but I have to multiply it by u prime. Yes? But if I ask you what is u prime, you would say that this is a constant, so its derivative is 0, and the derivative of this one is a, and I will write a here in front, so then it becomes equal to a cosine of ax plus b. But here we just showed that cosine of any angle can be written as the sine of that angle plus pi over 2. So if I give the role of theta here, even though this is a cosine, but I can write it in terms of a sine. Yes? So then this becomes equal to a sine of ax plus b plus pi over 2. Yes? So, and that is exactly what I want to show. I wanted to show that the first derivative of the function is a times sine of ax plus b plus 1 times pi over 2, but of course 1 times pi over 2 is just simply pi over 2, and we were able to show that. So this means that this is true. Okay? Now we assume that this is true for n equal to k. Yes, what does it mean? It means that the kth order derivative of f of x is equal to, I need to replace n with k everywhere. So this becomes a to power k sine of ax plus b plus k pi over 2. So this is assumed to be true. This is the induction's hypothesis. And now we want to show that this is also true for n equal to k plus 1, meaning that the k plus first order derivative of this function, we want to show that this becomes, I have to replace k with k plus 1 everywhere. Of course, this is the same k I am using everywhere. And then I should show that this is sine ax plus b. Instead of k, I plug k plus 1 times pi divided by 2. Yes, this is what I want to prove. This we don't know yet. Okay, but we know something. This is the k plus first derivative of the function. This means that I take one more derivative from the kth order derivative and I will get this. So we know that the left hand side of what we want to show is the k plus first order derivative, but k plus, let me write it, the k plus first order derivative can be written as the kth derivative, one derivative more. Yes, so if I take another derivative from the kth order derivative, it becomes k plus first order derivative. Yes, but the kth order derivative is equal to this expression because this is assumed to be true. So this means that I would write a to the k sine of ax plus b plus k pi over 2, one more derivative. But this a to the k is just a constant, so this I can pull it out. Then I will take the derivative of this function. Again, this is a sine function, so I will take this u in my head, so it becomes sine of u, and I will use this rule. once more. So what we have is a to the k. I told you, I pull it out. Sine of u becomes cosine of u, but I need to remember to multiply by the derivative of u itself, ax plus b plus k pi over 2 prime. But if I ask you what this is, you would say this is a constant, this is a constant, so the derivatives are 0. The derivative of this is simply a. I will take this a and put it here. A to the power of k multiplied by a becomes a to power k plus 1. Then I have cosine of ax plus b plus k pi over 2. Now again, if I refer to this formula in the beginning, any cosine can be written as sine of theta plus pi over 2. If I give the role of theta to this expression, I can write this as a to power k plus 1 sine of ax plus b plus k pi over 2 plus pi over 2. Yes? But then it is simple to see that I can factor a pi over 2 out from these two. So this becomes a to the power of k plus 1 sine of ax plus b plus, if I factor a pi over 2 out, it becomes k plus 1 pi over 2. And then I am done, because you see this is exactly equal to the right hand side. Okay, I will put the link to download the PDF file of these notes that you can see on your display below the video in the descriptions. I hope that the video was useful for you. Until the next video, be safe and goodbye.